Alright, hello SNC 2P Self-Lead Science students. This is our last lesson for chemistry, and we will be talking about types of chemical reactions. So if you've made this chart or you've printed it, great, because then you can follow along and write out what each of these chemical reactions are. So just like I did in my other lessons, I will alternate between red and blue. That way it's easy to see. So let's zoom out here and begin with synthesis. So synthesis can also mean, sorry, I'm just getting comfortable here, put together. So that means elements are coming together to form one compound. So typically that's A plus B creates AB. So key points, just sitting awkwardly in my chair here, fixed, scroll over. Key points is that we have we start with two reactants, but form one product. Okay, so let's focus on some examples, like how would we see that in real life? So let's say we have S, hopefully you know that's sulfur, plus O2. Together they form SO2. We have CO2, which is carbon dioxide, plus H2O, and together they form H2CO3. And let's keep in mind, there's only one S at the beginning, at the reactant side, one S on the other side of the arrow, the product side, 2 oxygen on the reactant side, only 1 oxygen on the reactant side, on the product side, which means we are always going to have the same number of elements in the reactant side as well as in the product side. We'll never make extra. That doesn't naturally happen in nature. And even in the second example, 1 C on the reactant side, 1 C on the product side. 2 oxygens with the carbon and 1 oxygen with the water. So that's 3 oxygens on the reactant side. And then here we see 3 oxygens on the product side. And last but not least, we only see 2 hydrogen on the reactant side, and we see 2 hydrogen on the product side. So we'll never make extra. We will always have the same amount of elements on both the products and reactant side. So application, where do we see a synthesis reaction in real life? Acid rain, and in fact that's actually carbon dioxide plus water makes this acid here. Alright, let's move on to the next. Whoops. My goodness gracious. Okay. Alright, now we are on decomposition. And just like, think about decomposing. So we are looking at taking apart, or to decompose, something is breaking down. Okay, so what does the general formula look like? Instead of A plus B makes AB, we're breaking it down. So A, B together makes A plus B. So to take apart or to break down. So, going to key points, I'm going to make it a little bigger so we can fit it. Larger molecules split into 2 or more elements / molecules. And then it's the opposite of synthesis. And requires the most energy to break down. Alright, now let's move on to some examples. We'll use the same one that we actually, since it's the opposite of synthesis, we'll use the same one that we used. So H2CO3 breaks down to water plus CO2. And this is another good one, NH4NO3 breaks down to N2O plus H2O. So on a test, I wouldn't ask you to figure out the products, but I would ask you, if I give you NH4NO3, the arrow, which means it makes or it becomes NO2 plus H2O, I would hope that you would see that as decomposition because it's a breakdown. So an application of this actually is explosives. Use decomposition chemical reactions. Nitroglycerin, which becomes CO2 plus H2O plus N2. So it's this breakdown of all of these. Curious, this is the chemical formula. C3H5N3O9. Okay. Let's move on to the next one, which is single displacement. Get my red. And to single displace means you bump out or switch out. Alright, so what's our general formula for this when using the A, B? We're going to actually introduce a C now. So let's say you have A plus BC. So one element here and then a compound here. We're going to switch out. So we're going to switch out. A is like, I want to be with C, or I want to be with B. So it could be AB plus C, or AC plus B. But the bottom line is, A, who was alone, is now going to be with somebody, leaving an element that was with another element alone. So to bump out or to switch out. So what's the definition we could use in our little box? Reaction of one element and one compound. Okay, so let's look at an example. And I'll do different colors here. So let's do an Mg plus AgNO3. So what does that look like? We could have MgNO3, and who would be alone then? The Ag. So that's one example. As we can see, Mg oops, let's use black. Mg was alone, and Mg bumped out Ag to be with NO3, so then that's why in our product side, we have Mg, NO3, and then Ag on its own this time. So that's what single displacement means, to bump out. So it might be helpful, tip, put elements in different colors. And it'll help you see if it's a single displacement or not. So what's an application in real life that we would see with single displacement? We might do this to extract an expensive metal from a compound. Alright, let's move on to double displacement. So double displacement, if single displacement was to bump out, we're gonna switcheroo. That's another easier way. So what would our general formula look like? A, B, so they're together, plus C, D, they're together. We're doing complete switchies. Could be A, C, A, D, plus C, B. Or it could be A, C, plus B, D. But complete switchies. So, what is our key points? Elements from two different compounds exchange, gonna need more space, exchange places to form, two new compounds. So let's take a peek at an example, and this time I'm going to have to use 4 different colors. So let's make it big. So first, let's put our guiding one at the top. So we're going to do, we're going to do A, B, plus C, D makes A, D plus C and B. Alright, let's actually do a real one. So let's say I have AgNO3 plus NaCl. So if we're following, if this is A, and this is B, and this is C, and this is D, and we want AD plus CB, I'm going to have AgCl plus CNaNO3. And there you go. That is double displacement. Switch 2 switches to form 2 completely new compounds. So AgCl is a completely new compound, and NaCl And NaO3 is a different compound than AgNO3. So what's an application in real life? I believe this is blue. Purification. We can see this in purification of hard water. Alright, we have 2 more to go, combustion and neutralization. You might have heard the word combustion, and combustion means something or to be a light. So here it is. And be a light or burn. Be lit up. So what are we kind of looking at? We're only going to focus on complete. So it would look like fuel plus oxygen breaks down to CO2 plus H2O plus energy. So that's what you would notice if I were to have this question on a test. It'd be fuel, so a fuel plus oxygen breaks down to CO2, water, and a form of energy. So we're gonna go right over actually to an example. So here is energy. Here's the source of fuel. And usually for a source of fuel, you'd see a lot of hydrogen and a lot of carbon coefficients here. And we know it's going to be plus O2. And you'll usually see a lot of oxygen as well too, hence the 25. And we know it's going to break down to CO2 plus H2O. And a lot of it actually too. So that's often kind of an indicator that you have a combustion reaction. You see a lot of carbon, a lot of CO2 molecules, a lot of H2O molecules, and energy. And what is an application of that in real life? Reaction of gasoline in a car engine. Okay, last but not least, I'm going to head over to our neutralization tab. And that means acid plus base. So if you've ever had a stomach ache and your stomach full of acid, what would you take? Usually you could take Tums, and that's a base as it neutralizes, so it kind of calms down the acid in your stomach. Which means, what does the general formula look like? Acid plus base makes H2O and salt. And that's really it. That's all I have, because really we won't focus too much on neutralization, and we'll focus on the other chemical reactions that we've talked about. So things to review and remember: what do each of these mean? So we know that synthesis means put together, decomposition means take apart, single displacement means to bump out, double displacement a complete switcheroo, and combustion means to burn or be lit up. Make sure you understand what the general formulas are and look at them from the examples. That way you would be able to identify it on a quick quiz that we would have next week. And that's about it. Please do the practice questions. I have the answer sheet ready to go if you need help determining what is which.